All right. We're going to be doing 5.1 notes. This one will talk about inverse functions and then converting forms and log forms. Log property will not be done here. It'll be done in 5.3. So we'll move that over. So kind of review us. We're talking about exponential log forms. They are inverses. So they are inverse functions. This means that they're x, which I'm going to call, I'm going to put x here. Remember, we're talking about domain. I'm going to use vocabulary so that we get used to making sure you hear that. And the y, which is the range. Values are switched. And we talked about this when we talked about log and exponential graphs. We talked about how they're switched when it comes to graphing them. So to refresh our memory, what I mean about switch, we have y equals, we had base of b to the x, where b was greater than 1. And then we did, and here we said the points, the critical points would be 0, 1, and then 1, b. We had to put b there because we didn't know what it was. We also talked about y equals log base b of x. And then we said that b had to be also greater than 1. And then that we switched the domain and range. 1, 0 would be the first critical point, and then b1. Okay, so kind of refresh what those are like. So the next thing we want to look at, so we're going to graph these two, sketch the graphs of parent functions. I'm here at A. F of x equals e to the x, and f of x equals natural log of x. So remember, these are natural log of x, same base is base e. These are inverses of each other. They have to have the same base, b and b. In order to have those two b's, they have to have the same base in order for them to be inverses of each other. So the first thing we want to look at first, we got to remember that e is approximately 2.718. We'll need that to know that to graph that. Okay, so sketch the graph parent functions, y equals e to the x, and then f of x equals natural log of x. So I know my 2 points off of this graph will be 0, 1. I know my other one will be 1, e. And in place of e, I'd put 2.718. So I'm going to graph that with one color. It says make sure you log in critical points and asymptotes. Oops, I should put that up here. Asymptote for this one. This is a horizontal asymptote. Remember, at y equals 0, and logs have vertical asymptotes, or x equals 0. Okay, so let me graph this one. I'm going to draw my asymptote first at here, asymptote, vertical asymptote, horizontal asymptote, is y equals 0. So that's here. I know I have a point here at 1, 0, 1, and then 1. E is close to 2, close to 3, so 1, 2. So don't put it quite on there. Make these graphs nice and pretty when you're putting them on the same thing, because we're going to talk about it, but make sure they're nice and neat. Okay. All right. Next one is we're going to do the natural log of x. So the natural log of x, our points are switched, as in the domain and range are switched. I say points, the values of them are switched. So I have 1, 0, and now I have E1. My vertical, man, I keep saying it wrong, asymptote is x equals 0. So I'm going to draw my vertical asymptote. Now I want you, when you're graphing these, ignore the blue because you're only graphing the log, the natural log on here, but we're just doing on the same axis. Okay, so now I'm going to go 1, 0, which would be right here. And then I'm going to go 2.71. E is 2.718, so 1, 2, close to 3 and up 1. So approximately here. Again, nice, neat graphs, please, so you can see what's happening here. Okay. So now what we're going to do, we're going to draw the next part. Now draw the line y equals x on the same grid. Remember, that is our parent function of lines. It goes through the origin. The slope is, so if you want to think about it, we have a slope of 1 and our y-intercept is 0. So we know it goes through here. And so here's this little, goes through here. And so we're going to dash this. We're not going to make it I'm not going to make a solid line so we can see something. So when I draw my line through here, okay. Now when you notice this, hopefully you see the question is, what do you notice about the two parent functions? What I want you to pay attention to are their points. So if you pay attention to the points that are on here, like this one in relation to this one in relation to this one, these points. And hopefully you see that they are reflected of each other. And they're reflected, what is they're reflected across this y equals x line. Usually we have it reflecting across the x-axis or the y-axis, but this what happens here. They're reflected across the y equals x line instead of x-axis or the y-axis. Now, when you draw inverse functions, like we show here, and exponential and log functions are, as long as they have the same base, are inverses, they will be reflected on here. We're going to do that, show examples on the other one. So for the other ones, this next group, it says graph each of the following inverse functions on the same axis. So if you look at every single one of these, they're going to be the exponential and the log one. If you can graph the exponential function, then you should be able to graph the log function with the same base. So what I'm going to do here is we're just going to talk about getting the parts that we need. So if we look at this first one here, it's an exponential graph. This is base 2. Okay, so if I'm in base 2, the 2 points I know I'm going to have is 0, 1, and then 1, 2. No matter what, that's going to have, I'm just having an exponential. This graph, though, is shifting down 1. Okay. And we have a horizontal asymptote. It did not, it shifted down, so that means your horizontal asymptote has to shift down. That right there tells you if it's just up or down. Okay, so this is what the graph should look like after it's graphed. So now what I'm going to do is I'm going to take, okay, now that I have my exponential graph graphed, I want to look at these points right here on this graph. Okay, those values are, we have, this is 1, 1, and then we have 0, 0. So these are the two graphs, these are the 2 points on that graph that I need, okay? So now when I do this for the log, I'm going to look at, it's still base 2, okay? I'm going to use these 2 points, and if I switch them, 0, 0 is still the same as 0, 0, and then 1, 1 is the same as 1, 1. So you got those. You have to get those because they have to be inverses from that graph that you've drawn, not from the parent function right now. Okay, this is telling me right here that I'm shifting over to the right 1. And the reason I need that is I need to draw my vertical asymptote, which changes to x equals -1. Now, again, I'm only using this for this. I do not have to plot my points and then shift. So I'm just going to plot my points now. 0, 0's here and 0's here. Okay. So, but my horizontal asymptote is x equals -1. So again, ignore the blue and draw this. When you draw this, it's going to come up, it's going to go over a little bit, and then come out. Okay. So I'm going to put this, both these points share this. Okay. Both those points. So my graph again goes up a little bit, goes over a little bit, not quite on the, on that. So they both share the same point. Now, if you were to draw I'm going to sketch it, the y equals x line, and it does go through there, you'd see the symmetry, but it might not be as easy to see sometimes when they're so close, okay? So again, I took the points from the exponential graph, the ones from here, to get these 2 points here, okay? So make sure that you are using that to help you to graph, okay? Also, put on the same axis, draw your horizontal asymptotes first, and so forth. So let's go to the next one. Okay, so now we're going to look at this graph, example number 2. Our exponential graph we're going to look at first. So we have a base of 3. not -3. If you go back up to our notes, we talked about how the base has to be greater than 1 and it can't be negative. Remember, the negative talks about the reflection. Okay, so -3. We know that those points would be that are critical for base 3 would be 0, 1, and then 1, 3. Okay, we know that the graph right here tells us we're moving to the left one. And then this negative tells me I'm reflecting over the x. Okay, so now I'm going to plot those points. I'm going to do this with you. Oh, horizontal asymptote. Okay, so our horizontal asymptote, though, because we didn't shift up or down, it's still y equals 0. That does not change. So now what I'm going to do is talk about graphing this. So I'm going to draw my horizontal asymptote here. Again, now depending on how you like to do this, depending on how you like to reflect or anything, which way you go first, graph it and come back. All right, after I graphed, this is what it looks like. I moved over 1 to the left and reflected across the x-axis. Now let's get our points off of this graph here that we've graphed. So we have a point here at -1, -1, and this point is 0, -3. Okay, so now when we go to our log graph, we still have a base of 3. Okay, we are looking at points -1, -1, because when those switched are the same, and when I switched the domain in here for the other one, it'd be -3, 0. Okay, so I'm gonna get rid of that arrow. All right, so now what did we need? Did we shift this right here? We kind of talk about these shifts in here. This, again, if it's inside here, reflects over the y. And then the other one tells us that we had to shift down 1. Now, I did not shift left to right, so my vertical asymptote is still x equals 0. All right, let me erase these points and then graph. Okay, here are the two graphs. Not graphed very well. If you draw the y equals x line, it's not as easy to see, but hopefully you see the reflection of the 2 points that are happening. So it's not always that easy to see when you see it. So this reflects over here, and this one stays the same. So there is some kind of reflection happening. It just doesn't look as pretty as the other ones. Okay, I want you to graph the next one. Remember, E is 2.71. Okay, here's my graph. We need these 2 points right here. Okay, this one right here is 2, 2. And the other one is actually 3 and 3.718. Okay, those are those two values that we have for those. Okay, so now let's do the log graph. Okay, so we know that it's still base E. Natural log is base E. We know we need these 2 points here, but they have to be switched. So 2, 2 stays the same. And now we're going to switch 3.718 and 3. Let me pause a second, make sure you understand how I got 3.718. When the original point of that we had from when we shifted over. So originally it was at 1E. So 1E is 1 up here to 2.718. 1, 2, close here. Then I shifted over to 1, 2, and then went up 1. Okay, so it's still at 2.718, but then I shifted up 1, which makes it 3.718. Okay, just making sure everybody understands how I got that. Okay, and then we have, according to this, we have a shift to this way 1, and then according to this, we shift up 2, and because I shifted to the right, I have a vertical asymptote. I said it right. X equals 1. Okay, so let's go ahead and graph that. Remember to ignore the black when you do this. You're only looking at the pink. 2.2, which happens to be on there, and then the 3.718. So 1, 2, 3.718, and 1, 2, 3, which is approximately there. So now you draw your graph, and it comes up a little bit and then goes through there. Okay, so there's your finished graph. So we're going to kind of look at this information we have, and we're going to kind of help ourselves to write these equations from going, like if you notice number 1 through 6 below says write the equation line of the inverse function. Okay, so now we're going to make an observation that we need to talk about so that you can write these inverse functions without having to graph them. So I'm going to look at vertical and horizontal shift. So this right here is a shift down, okay, on the graph that was exponential. So that gave us a horizontal shift down. Well, this one gave us a vertical shift to the left, 1, okay. Here on graph 2, we had a shift to the, left 1. And then down here, we had a horizontal shift down 1. So we went vertically and then horizontally. Okay, same way, same number. Over here, we had a shift to the right. So vertical shift to the right 2, which if you notice here, we had a horizontal shift up 2. Okay, here we had a vertical shift up 1, horizontal shift up 1, and then we did a vertical shift 1. So if you're noticing that these are switching, okay, so what's happening here, just want to kind of make sure that you see this, is that, you know, the horizontal shifts become vertical shifts. Okay, that's for this, and vice versa. Our vertical shifts became a horizontal shift. Other thing I want you to do is look at reflection. Okay. All right, we only reflected on this first one, I think, yeah. So this one, if you notice, this reflected over the x for the exponential, so then reflected over the y here, okay? So the vertical, reflections switch as well. So kind of write yourself a note that you're, so now when you're writing this as well, you gotta look at the shifts of the reflections, and the reflections will do the same thing. Will reflect over the x, will become over the y. And vice versa. Okay, so with that said, let's look at this one. I need to write the inverse of this. That means I need a log graph. So the first thing we want to do is we want to find the base. Base is 5. This right here plus 3 tells me I am shifting to the left 3. And I'm also having, since it's an exponential, the horizontal asymptote, y equals 0 doesn't change. Okay, just got to check to make sure that doesn't do that. So now if I want to write the log graph, so I have y equals log, okay, base b, which is 5. So remember we're using from above here, up here, these parent functions to help us to graph them, okay. Now I did not do anything with the x, because what's happening here, if this is shifting to the left 3, that means for this function I have to shift down 3. And my horizontal asymptote doesn't change. I don't really need to write that. I don't know why I did. So then we're just going to put x here, but if I go down 3, that's a minus 3. Okay. This is not the same as this. These are two different things. Okay, these are not equal. This is telling me I'm shifting down 3. If I did this, sorry, I didn't put a plus in here, this is telling me I'm shifting to the left 3. Okay, so don't mistake those. We'll do some more that you'll be able to see the difference. All right, next one. All right, we have base E and I have a reflection, reflect over the y, and this is telling me I'm shifting down 4. So now for my log graph, excuse me, what do I want? Okay, so I just want to know if we just stick with what we're doing, so we say y equals log, and we do e, because that's the base. Remember, log base e is still the same as natural log, so don't use log base e, change it to natural log. Okay, so if this went down 4, that means this has to go this way 4. Reflected over the y means it's reflecting over the x. Okay. Okay, so now I'll just put in my things that I need and say, so I have x plus 4. Now that I'm going to put this reflection goes here. So that's your answer. All right, you try the next one and see how you do. Okay, so this is what you should have gotten on this one. Log base 3, x plus 7 plus 5. All right, so let's finish these last 3. This time we're going to go to exponential form because we already have log form, so the inverse of a log is an exponential form. We have base of 5, and this is telling me I'm shifting to the left 3. So for my new graph, or my new equation, y equals base is 5, and then I'm going to go down 3 because of this. So I don't have to worry about anything with the x, so it's going to be x minus 3. All right, this next graph, I have base 2. This is shifting to the left 1, but this is telling me to go up 5. So for my other graph, y equals, and then we have a base 2. This one, though, is going to tell me to go down 1, and then this way 5. So when I write my equation, it'll be x minus 5 minus 1. You try the next. Okay, so I had a base e reflect over the x, and I had to go up 8 based on this one. So my exponential graph had to reflect over the y, and then I'm going to go to the right 8. So make sure that you pay attention that this whole entire thing is because we have this minus 8 with it, you have to make sure that you put this on the outside, the negative, to reflect over the y.